All right, our next speaker is she works on the Debian project. She's on the Debian Clojure packaging team, and she also helps the Debian Java packaging team. She works as the software development lead at Rackspace Management Security Defense Infrastructure team. I had to write down that. Where she writes Clojure. The reason I invited her to speak was because as a software platform, as a language, it's very important to be out there in the software ecosystem that we all live in. And Debian is an important piece of infrastructure, and we need to be on it. We need to make it easy for people to set up Clojure on their machines, their servers. All of that takes work. It doesn't just happen for free. You have to set it up yourself. You soon see the pain of it. But it's easy because there's one command that installs it. And the person who makes that command work is our next speaker, Elana Hashman.
Hi everyone. You awake? Had your coffee? Oh yeah, come on, the more. Okay, this is not my slide. That was my test slide. So, hello everyone. It's awesome to be here. Buckle up because it's going to be a ride. I'm Elana Hashman, and today I'm representing the Debian project as lead of the Clojure packaging team. I want to tell you about all the cool work I've been doing to make apt-get install Leiningen a reality on Debian-based systems. If you want to live tweet the talk, my Twitter handle is @ehashdm, and the hashtag is ClojureSync. Let's get going. So, in this talk, I want to take you on both a historical and technical deep dive. I'm going to start by telling you about what Debian is and why it exists. We'll follow the story of reviving the Clojure ecosystem in Debian, which centers around Leiningen, and I'll use this to illustrate some of the benefits of downstream packaging and what building Clojure software the hard way looks like. Finally, after learning every insignificant detail about how that works, I'll conclude by telling you about our next steps, and we'll wrap up with some Q&A. Just to start off with a quick poll. How many of you have heard of Debian? Okay, most people in the audience. How many of you use Debian? Wow, that's a good number. Stretch goal. How many of you have contributed to Debian, like a bug report or a patch? Like 3 people, amazing! You rock. Well, so for those of you who aren't super familiar with Debian, I want to tell you the story of how the project came to be. This context is important to understand the work I've been doing and why anyone would volunteer to do it in the first place. So we're going to take a quick trip back to the 90s. And in the 90s, commercial software is king. Microsoft is making billions selling Windows and software for Windows. When I want to buy a new program, I head to Best Buy, I wander through the software aisle, I browse through all the boxes so I can purchase my new commercial proprietary floppy disk and take it home. Software was something you purchased at a brick and mortar store on physical media. Free software and open source, as we now know it, is for the most part this fringe hippie movement confined to university campuses. The GNU project was the heart of this movement, and they had the sort of David and Goliath goal of developing a free operating system to deliver the people from the inescapable grip of the commercial software market. So, starting in 1983, they worked very hard to ship all the software required for an operating system. C compiler and shell, text editing and processing software, the works. By 1990, they just needed a kernel to run it on. But the Herd project, that kernel effort, was, for various reasons, delayed. So in 1991, a student from Finland proposed his own attempt at a free kernel on Usenet building off new tools. He says, emphasis mine, I'm doing a free operating system, just a hobby, won't be big and professional like GNU. I've currently ported Bash and GCC, and things seem to work. Some of you may recognize this as the announcement of the first Linux kernel. But we have to keep in mind, this Linux is not an operating system as we know it. This is just some random student's side project. If you happen to have the right Intel hardware and the right kind of hard disk, you could maybe install and boot this kernel. it comes with no batteries installed. All we've got is a copy of Bash, the GNU shell, and GCC, the GNU C compiler. A shell and a compiler are kind of the bare minimum for being able to run a computer at all. Whereas compared to commercial alternatives in the early 90s, Windows and Macs came bundled with lots of powerful software, much of it with GUIs. And here we have this hobbyist student project that barely has a functioning command line, let alone software to run. So free software is still relatively novel in these days, so the fact that Linus's kernel was free was relatively notable. Building a free kernel was only possible because the tools it was built with, GCC in particular, were free software. It seems almost incomprehensible today, but prior to the development of GCC, most language implementations were proprietary. If I wanted to run C or C++, I'd have to buy a copy of the Borland or Turbo C compiler. Hence, this is a pretty awesome culmination of all the efforts thus far to bring a fully free desktop environment to people. We have a free C compiler, free shell, free kernel. And undoubtedly that led to its popularity. Anyone was allowed to use compiler share. But how do we get programs on this? Indeed, getting the software to run was kind of a pain. Software you'd purchase at Best Buy is not going to work on Linux, and the infrastructure to obtain free software just doesn't exist yet. There is no 90s GitHub you can grab your latest copy of Node from. There isn't even a 90s SourceForge you can grab your latest copy of phpMyAdmin from. It is the 90s, and your options to obtain source code and binaries are the disks from your local computing club, Usenet, where we found Linus's post, and perhaps the local FTP server. And those last two options assume you had a network connection, which wasn't common at the time. So this Walnut Creek CD from 1992 is a great example of how people shared software back in the day. GIFs galore. Yes, GIFs were quite popular 25 years ago, and in case you were wondering, there are like 72 different cat GIFs on here. Not that much has changed. So, now that we have this Linux kernel to run our GNU software on, maybe we could bundle that together as a single distribution. GNU Linux, if you will. And now that it's all in one place, we can share it on CDs or floppy disks. So Linux distributions, as they're now more commonly known, were created in order to distribute software to users. Many groups tried their hand at putting one of these together, but most that came out before 1993 didn't actually last very long. Personally, I suspect this might have been related to the branding. Now, Debian doesn't get to lay claim to the title of oldest Linux distribution. There were others before it. But it was one of the first, and more importantly, it was the first fully free Linux distribution. As we know, every good free software project started with a manifesto some guy wrote, and Debian has one of its own. Hacker and computing culture in the 80s and 90s produced a lot of manifestos. And honestly, when I look back on this one in hindsight, I don't find it that inspiring. In particular, it berates other work in the community to puff up what would become the Debian project. Rather, I'd like to think that what inspired the community to develop this distribution was the vision of a fully free operating system, the opportunity to build and shape a practice of free software. Because in the era of the Microsoft monopoly, when every piece of software you ran had to be purchased from the store and didn't come with source code, that was kind of revolutionary. Today, Debian is still 100% free software. 20-some years ago, in 1997, 95% of the free software written on the planet was packaged in Debian. As a result of the project's commitment to software freedom, anyone can reuse the work of Debian developers and derive from it and make changes at astonishing scale. To me, this is possibly the most important thing about Debian. We make sure free software works, and we use our reach to get it into the hands of users. We are the boots on the ground that package, build, and distribute thousands of projects, independent of their upstream developers, and ensure everyone can build this stuff. We've been leading the community recently with our reproducible builds project. The idea that, given a consistent build environment, we can produce byte-for-byte identical builds of software so end users can verify the binary they received actually corresponds to the source code that came with it without having to trust us. Debian is special because not only are we one of the oldest and largest free software projects in existence, but because the project is built around furthering the practice of free software, not just the ideology and theory. The other thing that's special to me about Debian is that it's 100% built by volunteers. Without getting into the ethics of volunteer labor in open source, I want to talk about a very important result of this, namely that Debian is built by users for users. In the Debian social contract, which every project member agrees to uphold, we assert that our top priority is serving our users, and I think that's really wonderful. Debian is an incredibly international project. It has users and contributors from over 100 countries around the world, and is translated into dozens of languages to ensure that people who don't speak English can still use our software. We take special care to ensure that Debian doesn't just work in the average conditions of a tech office in San Francisco, and that it isn't primarily driven by corporate tech interests, which helps make our software accessible throughout the world. Debian is free, and Debian is for everyone, and I think that's what has made Debian so prolific over the years. To this day, Debian has thousands of contributors, and contributions to the project affect millions of users. You might even be one of those users without realizing it. I had to flip this graphic on its side because it didn't fit on the slide. So this is a graph of all Linux distributions derived from Debian, starting in 1993 with time elapsing downwards. I think Ubuntu is relatively popular. How many of you have heard of Ubuntu? Basically everyone. So Ubuntu, possibly the most popular Linux distribution, is just one of hundreds of Debian derivatives, including Kali Linux, Linux Mint, and Knoppix. Just like you might fork a repository on GitHub, the developers of these new distributions forked the whole operating system. So for example, Ubuntu started with all these repositories of free software built into Debian, and then their developers added some stuff on top of that. And the two projects are tightly integrated, so any packages or updates that I upload to Debian automatically get included in Ubuntu. Cool, huh? Now these days when I go to dev meetups, like everybody uses a Mac and they usually build their software in Docker containers. But Debian is not kicking butt as a base Docker OS. 7 out of the top 11 images on Docker Hub use a Debian base, 8 if you count Ubuntu. This is to say, it seems the majority of Docker containers run on Debian. So, great. Debian sounds kind of cool. It was historically necessary to distribute free software, and it made a case that it's still pretty popular. But why would users want to use an OS-based distribution instead of installing from upstream these days? Anyone can clone the source on GitHub or visit a project's website. It's not like we need CVs anymore. Well, as someone who's worked for a number of years as a professional software engineer with a particular focus on building software, I will say that this is a skill often taken for granted. Getting software to build and work on a system is hard and requires a lot of knowledge about that system. It's not a black box abstraction. You have to know how every single piece of it works. If, as a developer, I want my software to be as accommodating as possible to end users, asking them to complete even simple steps like unpacking a tarball can be a pretty serious obstacle. Like, unpacking a tarball is actually quite difficult. In fact, it's so hard that some people founded a whole documentation project called TLDR because they couldn't remember the flags to use tar. So, telling users just to download or build from upstream is not a great option. They might not know how. And that's without considering a security perspective. I work in security, and we have been trying to convince users for years to not install random binaries they find on the internet. But in the age of, well, just curl this script into a root shell and install it, I feel like we've lost some ground. HTTPS is not going to save you if you accidentally download from a malicious server. It's really hard for users to comply with only install software from trusted sources directives when they don't know how to determine what is and what isn't a trusted source. And even if I manage to get software securely from upstream devs, it still might not work. I can follow and do my best to do all the steps and more to get installation, and in the end, it still doesn't work. I get this error about Java not found. Why? Well, that's a prerequisite dependency on JVM. But maybe a beginner doesn't realize or understand that. So they've gone through all this trouble to figure out how to get this stuff, and now it doesn't work because they need to get Java? Why wasn't it installed already? What version of Java should they get? What if it breaks the other installation of Java they have on their laptop that isn't compatible? This is a giant headache I don't want end users to ever have to worry about. Linux distributions are software ecosystems. We don't just test that you can install software, but that you can install and configure software and it works together. We ensure that, as an end user, You don't ever have to know that shell check is written in Haskell. That's irrelevant, because you're just running the compiled executable on command line anyways. In addition to there being value in having one true location-defined software, users also value the integration testing and dependency management OS developers provide for them. So, from a user perspective, users get the best experience if there is one true way to install software, like using apt-get. That way often comes with the best built-in security guarantees too, and handles dependency management and software compatibility. This one true way doesn't have to be the official Debian or Ubuntu repos. It might be an app store. And just like how app stores have security teams that monitor for malicious applications and vulnerabilities, Debian's security team patches vulnerable software and posts public bulletins to ensure that users can keep their software patched and secure. And just like how app stores will require you to install required services for any apps that you download, Debian will manage your dependencies. And installation is easy. For users uncomfortable with the command line, there are many GUIs available to replace aptitude commands, meaning users can just point and click to install software. So, as a result of Debian and its derivatives' popularity, if I want to ship software to users on a Linux desktop, packaging and uploading that software to Debian means that millions of people can now just apt-get install those packages, and they can run the software, rather than having to worry about running a shell script they might not understand, or trying to install an executable if they've never even heard of the path. In addition to the benefits for end users, I think that packaging software for Debian also benefits the developer community. But rather than just telling you so, I'm going to share the story of how I've worked to revive the Debian Clojure ecosystem and how the upstream developer community has benefited. So, what happened to the Clojure ecosystem? Why did it need reviving anyhow? Well, people did the work, and then they moved on. I mentioned that one of the awesome things about Debian is that it's 100% volunteer-based, which means volunteers really care about the users they serve. But at the same time, if a volunteer loses interest, or they lack the free time to work on something, or they have a family emergency, someone else needs to step up to maintain things. Sustainability is a big problem. In the case of the Clojure ecosystem in particular, many of the uploaded packages were put together by a GSOC student that stopped working on Debian after his GSOC internship was over. So those packages sat more or less unmaintained for 3 or more years. Many had simply been removed from the archive. So, at my first conj in 2016, my friend Tom Marble, hi Tom, and I were discussing how the state of things in Debian had gotten so bad. Leiningen hadn't been in Debian for 3, almost 4 years at that point, and the last package version was 1.7, woefully outdated. The latest release was 2.7.1. It had even been removed from recent releases of Debian. So he's trying to convince me to work on this, and he introduces me to Rob Browning, who's the Debian Emacs maintainer and a fellow closer, to try to sell me on this project, like Star Power or something. So we're all discussing the state of the Debian ecosystem of Clojure, and Tom says to me, you know, Elana, we really need more women in Debian. Why don't you pick up packaging line? And I think my response was, Tom, I barely know how to put a Debian package together. I couldn't possibly do that. Besides, no offense, but who's stupid enough to commit hundreds of hours of unpaid labor to a project that they have to maintain indefinitely? So, there are a couple of reasons I'm really excited about packaging of Leiningen and why I wanted to talk to you about it. First, in my mind, since Clojure 1.8 was already in Debian, Line was this missing center of the Clojure ecosystem. It's the most popular Clojure build tool, which I measure very scientifically with GitHub stars. And it's relatively stable software, meaning it updates infrequently, and the dependencies don't change very often. Yet, for some reason, no one had packaged it. I didn't know how to do Clojure development without Leiningen. And now, having seen the other side of things, I would not want to. If I could do something to fix this, I thought, well, maybe that would be valuable. Second, it's a complex package with many diverse dependencies, which makes it an interesting illustrative example. Reviving the Leiningen package was a bit of a journey, as you soon will see. So, after this chat with Tom and Rob, I did attempt to follow my own advice for about 2 months, after which point it was pretty clear the person who owned the ITP That's an intent to package, the bug which says you're working on packaging a certain piece of software. That guy was not coming back, at which point my curiosity overwhelmed me. So I figured, okay, well, I'll just help out a little bit with some paperwork for the dependency versions. That's not that hard. So the first thing I did was build a dependency tree to see what dependencies one would need in order to package one. Here's that tree. It's kind of long. That's a 10-point font. And actually, that's not Leiningen's full dependency tree. I couldn't fit that on the slide. So, deep breath. The next thing I did was, for each dependency, I identified whether it was in Debian, and if so, if the version in Debian matched that of the Leiningen dependency. There isn't really an automated way to do this, because there wasn't a standard naming scheme, so I just checked them all and manually came up with a list. Like, hey, I figured out all the work we need to do. And once I finished that, I sent an email to the bug for work file on package. Debian's bug tracking system is 100% email-based, so anytime you want to update a bug, you just send an email. Less than a curse. I guess Tom was really impressed with my list, so he formatted it with Wiki Markdown and put up a whole wiki page for it. And he also pulled in Phil Hagelberg, the author of Leiningen, into the email thread to let him know where we were at. One of the few advantages of using an email-based PTS. Phil was super friendly and helpful and accommodating, which was a great experience. I cannot express how wonderful it is when you're working on a package and upstream is cooperative and friendly. Sadly, this is not the case with every project. So, once that dependency tree was available, Phil took a look at it and said, well, it'd be awesome to get Leiningen and Debian, so maybe there are some dependencies we can remove to make the packaging easier. With the removal of Cheshire and Clojure HTTP, for example, we dropped at least 7 additional transitive dependencies. Which is a good segue into the first key benefit Debian contributors offer upstream projects. We contribute patches and encourage the improvement of upstream code bases. In the case of some of the unnecessary dependencies, we helped remove complexity and reduce the binary size, where those dependencies weren't strictly needed. Remember, Debian developers try to consider all of our users, and much of even the United States outside of urban centers are still stuck with dial-up or satellite connections. So even kilobytes of download size can count. With the packager pestering upstream, there's an incentive for upstream developers to fight security bloat. Another thing Debian is able to help with is application security. As part of my dependency review, I discovered that Leiningen was depending on a rather old version of Maven via one of its dependencies, Pomegranate. It turns out that this version of Maven had a median severity CVE, which is a security vulnerability bulletin for those of you unfamiliar, and that had gone unnoticed for over 4 years. A bad configuration default in Maven Wagon disabled all SSL certificate verifications on HTTPS requests. What this means is that if you open an encrypted connection, you don't bother to verify you're talking to the right person, so if an attacker hijacked your connection and sent you malicious code, you'd have no idea. So, kind of scary. I freaked out thinking that this meant for 4 years, you would not have been able to trust any dependencies you downloaded via HTTPS using Leiningen. That would have been terrible. Funny enough, Leiningen actually fixed the vulnerability by accident, overriding the version of Maven Wagon to fix a different bug in configuration. So, while Leiningen was not vulnerable, Pomegranate prior to the 0.4.0 Alpha 1 releases is vulnerable. So I'm currently in the middle of a request for a CVE to encourage people to upgrade. If it's granted, this would be the first CVE filed against a piece of Clojure software. So please upgrade. I know some of you are using Pomegranate on the old versions I saw on GitHub. Tell your friends. So this is a big benefit of having downstream maintainers. Hopefully we won't have to worry about this sort of thing going unnoticed for years again, because we'll have someone like me double checking. So once upstream had helped us out by cleaning up everything we possibly could, then the ball was in our court. We had something like 6 new packages to upload, at least 4 packages to upgrade to a new version, and as it turned out, a bunch of other packages needed their packaging fixed. So let's do it. Let's figure out how Debian packaging works. Debian packaging can get relatively complex, but at its heart, the core components are pretty simple. Debian packaging needs to be as widely compatible as possible, so it can't be language specific. At its heart, Debian packaging consists of 2 things: a tarball of the original upstream source code, and all the Debian paperwork we need to build it. and the main components of that paperwork. Control file, the rules file, change log, and patches. So we'll take a quick look at each by walking through the packaging of a Clojure library Scout. So first, this is a control file. The control file is where we list important metadata about the package, like the name of the package, the maintainer, the build dependencies, a link to the version control repo for the package, the binary name and architecture of the built package, the runtime dependencies, and a short description about the package. Next, the copyright file, where we list all copyright information for files in the package. This is critically important because we have to establish that we're actually permitted to build, package, and distribute the software. This file will contain copies of licenses and state any copyright holders for software in the package. Note that the Debian packaging itself does not need to be licensed the same as the upstream software, although frequently packagers may choose to use the same license to ensure patch compatibility between upstream and downstream. This is a rules file, which is basically a make file for building the package. These can be extremely simple, or they can be very complex, depending on the helpers available for building a specific package in Debian. We're going to come back to this one, so don't worry about it too much for now. Next, the change log, where developers indicate the version of the packaging and write down any changes they've made since the last version. Remember, Debian packaging predates widespread use of distributed version control, so this was kind of how they did that. And last, any patches that need to be applied to the source code prior to attempting the Debian build. Scout didn't have any, so this example is from Leiningen. Here, I modified the original project.clojure in the source code to build offline and set the local Maven repo location. So essentially, making a Debian package, just better filling out some paperwork. If you have dependencies already in Debian, you reference them in control. If not, you package them and upload them, and so on. The most complex thing that changes from language to language is how to fill out our rules file. How do we build this piece of software? On the Clojure side generally, libraries or applications are built one of two ways, with Maven or with Leiningen. And I'm not forgetting about Boot, by the way, I just didn't encounter any libraries that needed Boot. But we don't actually have Leiningen available to build these packages, and Scout is a library that builds with Leiningen, so there must have been some other way to build it. When I first saw this, I was kind of confused as to how it worked. So let's go over its rules file in a little more detail. To build Scout, we need to produce a jar, as though we were calling line jar in the root of the Scout repository. For our rules file, the name of the produced jar we build is scout.jar. We see the main part of our build, ; invokes DH or deb. We add on a couple of build-specific modules to help us with our code, the Java helper and Maven repo helper. Since we're building a Java jar, Java helper can assist us in doing so in a Debian-compliant way to ensure the jar is installed in the right place and is configured properly according to policy. We need Maven repo helper for ensuring that once the jar is installed, it's also listed properly in the Debian Maven repo so that any software that builds using Maven, which is what Leiningen uses for dependency resolution, can find it as a dependency. Now, I think the really interesting step is in override JH build, where we override the normal Java helper build. Instead of what that does, we call the jar command, which creates an archive called scout.jar, that's the produced jar, in the current directory, using all the classes in source, that's the --C flag. So all that does is create a jar that's an archive of the source code from the current directory. That's it. When I first saw this, I was like, WTF, does that work? To give you a little more context around what's happening here, let's take a look inside a regular, boring, old Java jar. Jar stands for Java Archive and is based on the tape archive or tar format, which we mentioned earlier. Hence, we can use the same flags to jar as we would to tar for listing, extracting, etc. I've got those all memorized, so let's take a look at some jar guts. This is just a random jar I found installed on my laptop, the GNU gettext jar, and it's got some directories and files inside. First, metainf. This is the directory where the metadata for the jar is stored. In particular, we see it contains a manifest.ml file, which contains some important info about the jar, which we'll take a look at in more detail. We can also see some class files under the GNU gettext namespace. Each is a separate file in the jar, with an archive timestamp, just like a regular tape archive. Now, if we extract the contents of the jar, we can take a closer look at the manifest file. So let's do that. Now, this one is pretty bare bones. It specifies the manifest version format and the version of Java this jar was compiled with. Java 7, because I'm rolling old software. But you can also specify other important metadata in a manifest, such as which class in the jar is the main class. Manifest can also specify class paths. A Java class path is basically a list of dependencies that a jar needs to run. This is similar to an R path in ELF files, if that's something you've previously encountered. So, let's take a look into the jar my Debian build produced. Very simple, and that Clojure code inside the jar? Well, let's compare to when I built the same library with line jar. So, we've added a bunch of Leiningen and Maven metadata in the meta-inf directory, that's for sure. But the guts are the same, so do they work the same? Let's try out our Debian jar. So one of the things I never thought I'd have to do prior to embarking on this project is invoking Clojure directly via Java, but here we are. So if you haven't done this before, I don't blame you, but here's how we do it. First, we put the Clojure jar on the class path, as well as any project or library code that we want to compile. So that's the -c key on the first few lines. And then we invoke the Clojure.main function with the argument -e and a code snippet. So in this case, I just want to see if I can use Scout as a dependency. So this command is essentially a compilation test. We see that Scout is up there in that class path, so let's see if this works. Indeed, it works if I run this. And after executing, here's some log messages indicating Scout's peak successfully overrode Clojure core's peak, and it exits with a status of 0. Cool. So what the heck is going on here? How does this even work? Figuring this out gave me some insight into the dark magic of how the Clojure compiler works. So here's what I think I learned from embarking on this somewhat tedious exercise. First, Clojure is just a jar, 3 jars in 1.9, but let's not split hairs, from which you invoke Clojure.main. The Clojure main function invokes the Clojure compiler to do all the heavy lifting. Second, and this was the most important discovery, I think, class paths are the sauce of how Clojure actually works. It ensures dependencies and project code are visible to the Clojure compiler, which then consumes those resources and executes the code. Leiningen did an extremely good job at hiding this from me outside of the occasional blah blah not located on class path error, which meant nothing to me because I never had to manually specify a class path. And last, Clojure libraries are basically just source targles. So putting 1 and 3 together, we can sort of derive the fact that Clojure code is JIT, or just-in-time compiled. Neat. I assume I'm going to get asked a lot of questions about this slide, so make sure you pass those to Eric. So let's put all we've learned together and build this. It took recording because the chances I could pull this off in a live demo are basically 0. Hey, and done. Cool. So we built our jar with Debian tools. Almost good to go. Now we just do this like 12 more times. Each of these dependencies now needs to be uploaded and accepted into the archive, and then we just rinse and repeat. Finally, we get to the pièce de résistance, build in Leiningen. So the guts of how Leiningen builds are actually pretty interesting. Leiningen is structured as an inner project, Leiningen core, which can be built with Maven, and the whole project, Leiningen, which builds with Leiningen. This is what we call a bootstrapping build, and they're relatively common. The most famous might be GCC, which we mentioned earlier, but Clojure 1.9 also builds in this way. And as anybody who's done a bootstrapping build for the first time will tell you, they are a pain to bootstrap for the first time. So, my plan was, in order to get Leiningen to build, I had to ensure all of its dependencies were available in the local Debian Maven repo. And then the structure of that repo should allow Leiningen core to find its dependencies during the build. So we just needed to build Leiningen core the hard way, and then once that was available for the outer Leiningen build, it should just work. Okay, so good game plan. We just got to build Leiningen core somehow, right? Should be good to go. Turns out this was a little more difficult than I expected. To give you an idea of the scale of this step, it took about 4 months and half a dozen different build ideas before I finally found one that worked. But finally, I was able to get a working Leiningen core with Maven after trying a few different ideas. Which brings us to Debian benefit number 3, which I hope I earned. We make sure upstream actually builds from source. The main reason I investigated building Leiningen with Maven was actually I screwed up. I forgot to set this environment variable exporting line version. As a result, when I tried to build line core by sticking the source in a jar, it complained at me about the missing version property in the Maven metadata. So I said, fine, I guess I'll build it with Maven, I need this metadata. And upstream even checked in a POM, project object model file, that's kind of like a project.clojure for Maven. And they had this commit message about, we want to help upstream developers build the project. So I thought, great, amazing, upstream is so wonderful. But there's a slight hitch. As that POM file was written, no source code was actually getting included in the Leiningen core jar, it was just generating a POM. So I was like, what the heck, has no one ever used this? Hasn't anyone tried to build this from source? No. They couldn't have, or it would have worked. And to be clear, I don't think this is unreasonable. With a bootstrapping build, there's not really much point in upstream trying to build this from scratch again. They can just use the previous version in order to build the new version. Nevertheless, I think there's a lot of value in people being able to build a project outside of the upstream developers. Source code is pretty worthless if you can't actually build it. Outside of something like the reproducible builds project, it's the only way to ensure your binary corresponds to the source code you got. And upstream isn't necessarily going to support older computers or architectures. So this is crucial if we want to keep them alive with new software. For example, I cannot get Leiningen to build on 32-bit architectures for some reason. So I wrote a patch, which fixed the problem, sent that upstream. My build started working. This was great. But the whole time I just kept thinking, this can't possibly be it. Surely somebody has looked at this before. I probably should have known better. Security researchers call this the many eyes fallacy. Just because source code is open doesn't mean anyone's actually looking at it, OpenSSL being the prime example. When you do this kind of work, you end up working as a trailblazer. No one's done this before, well, at least not recently. So you've got to believe in yourself. So, here's most of the important guts of the Leiningen rules file that actually works. First, I had to figure out how to trick Maven helper into building Leiningen core and install that somewhere accessible to the rest of the build. Normally, that tool requires the pom.xml to be in the root of the repo, so this trick was the key to the build, setting the build directory properly. Once I figured that out, the rest went relatively smoothly. Now, once I had the Leiningen core jar built and installed, I was able to use that to build the rest of Leiningen. This project is a little fragile because normally what you would do is you'd run Leiningen to find all its dependencies to generate a class path with the line bootstrap step. You may see there's a variable defined here that we wrote into the .line bootstrap file. Now, this is how we generate the contents of that file using the special Debian versioning scheme and our knowledge of the dependency tree to figure out where all the various jars live in the local Maven repo. Now, I included all the jars that fit on one line on that slide, but there's actually 42 in total. So in the future, now that we've bootstrapped once, we can generate this with Leiningen. But so long as we don't have Leiningen around, I had to put this list together by hand. That is the bootstrap. So, remember I mentioned that class paths, such as this one, are the Clojure sauce. What we've learned today is that bootstrapping the Leiningen build in Debian just boiled down to building artisanal class paths lovingly handcrafted in Brooklyn, New York. And with that, we have a build. In comparison to the libraries, this one has a lot more going on. I have to show you the video, or else you might not believe that the gibberish on that rules file slide meant anything. I did not draw a single pentagram to make this build work. Hey, look, we're compiling Leiningen. AOT compilation, going fast. All the fancy color text is the output of the various Maven builds. I sort of have a visceral reaction when I see those now. More compilation, more Maven. Oh, hey, we got all the Debian steps. And we're done. Huzzah! Upload time. Let's just send this over to the archive, and except I actually got rejected for not explicitly writing my name down in the copyright file. Apparently, refer to changelog was insufficient per the close public license requirements. Thanks, Rich Hickey. So we fixed that up, and Happy New Year. Leiningen was accepted into the archive on December 30th, 2017. And you can install it. You can totally install it. I uninstalled it and reinstalled it like 3 times to convince myself this is actually real. But it's real. That's the version I packaged and everything. So, what's next for you? About that whole indefinite commitment thing. So Leiningen is not the end. It's sort of the beginning. The Clojure team has all sorts of interesting projects ahead of us on our roadmap. On the packaging side, we have Clojure 1.9, tool steps, Clojure command line script, and boot. It would also be nice to improve our tooling such that we can build Clojure packages with Leiningen instead of the hard way. If there are other interested packagers from other distros as well, I'd love to reach out to them and share insights about the obstacles we ran into. It's great that Leiningen is now available on Debian, but what about Fedora or RHEL-based distros, for example? So, we'll just keep on swimming. I can't escape from people filing bugs against me, so I guess I'll keep fixing them. I wanted to give a quick shout out to all the awesome people that have joined the Clojure team. 2 years ago, I didn't imagine we'd have any volunteers, let alone this many. So this is a quick overview of all the members of the Clojure team and our current projects. What a long, strange trip it's been. So packaging Leiningen exposed me to a wide variety of things I never intended to throw myself into. As of a week or 2 ago, I realized that since I started work on this project, I have worked with upstream developers to patch and improve their projects, learned 3 different build systems for Clojure, filed a CVE, encountered not 1, but 2 different bootstrapping builds, built out a whole team of Clojure developers in Debian, and received upload rights and full membership in the Debian project. I even, oh thank you. I even learned how to write man page markdown, which is the worst thing, you should never do that, and that was my first patch accepted into Leiningen upstream. So, telling you about this lets us trace a journey from, I don't really know that much about packaging, to, I now maintain the entire Clojure ecosystem in Debian AMA, and I'm hoping that outside of the technical ground we covered, this might give you the confidence and courage to slay some technical dragons of your own. I believe in you. So, AMA, we have so much time for questions. Where's Eric?
So volunteers are walking around trying to get some questions out of you.
I want some really good questions.
Yes, please. You mentioned that one of the things that Debian package maintainers do is they improve upstream.
Yes.
Could you give us some more examples of how you do that?
Sure.
Documentation and stuff like that.
Yeah, so I mentioned documentation. I rewrote the Leiningen man page. I mentioned as well, I patched the upstream POM for line 4. There are a few other weird random things. Like for example, a lot of upstream maintainers don't tag their releases, like git tag. That makes it really hard for downstream to actually find the software that we want to build. So for example, I filed a lot of bugs being like, please tag your releases, thank you, so I can get a tarball. Because GitHub will actually generate a tar.gz file for anything that you actually have a git tag for, but makes it really hard if you try to do a specific commit. So.
Okay. Someone is asking what your Twitter handle is?
@e#dn. Like DN, like distinguished name, like LDAP. Yeah, it's a bad LDAP joke. Okay. I also tweeted a bunch on the hashtag, so you should be able to find me there.
So, have you been working with the Java team?
Yes.
How does that work?
So I'm also a member of the Java team, and so there was a little bit of confusion as to do the Clojure packages belong to the Java team because they're all built with Java tools, do they belong to a separate team? There was a concern that previously, the Clojure team went totally AWOL. There was nobody working on these packages, so maybe it should all be one team to ensure Java people can step in. But now we have a lot of active people, and the thing is, particularly if you go write a line helper or something, as opposed to a Maven helper, people shouldn't have to know Java-specific stuff to work on Clojure stuff and vice versa. So DebConf, we sort of came to an arrangement that pure Clojure stuff should live within the Clojure team, but we have a lot of cross-pollination between the teams. So Emmanuel Borg, I mentioned him on like the Clojure team slide. So he's actually like exclusively a member of the Java team, but then he also was the one who kept all the unmaintained packages alive while like nobody was doing any work for 4 years. So like, you know, he, for example, has access to the Debian Clojure repos, and vice versa. Like I have access to the Java repos and so on. So, in part just to like migrate stuff.
Were there any Java packages that Leiningen relied on? That
Yes, many. So like Maven, let's see actually.
That weren't in Debian already?
Not in Debian already. Actually, there might have been a few, but basically I filed some bugs against the Java team, and I was like, yo, Java team, help me out. I need these jars, and they were like, hey, we'll do that. But I think mostly I was just requesting version upgrades. The Java team is actually a very large team. When I joined the team, it had something like, so yeah, you can see like there's the Guava jar, Commons IO, SLF4J, JSoup, lots of Java stuff. Maven, of course. But yeah, they do a really, really good job. They're a giant team, 190 people, and they're constantly uploading and staying on top of stuff.
Great. And are they helping you in other ways?
Emmanuel actually advocated for me when I applied to become a Debian developer, and helped me out a bunch when I was trying to figure out how do I get Maven helpers to like not build in the root of the repository? Like he wrote that tool and there's no documentation. So like emailing was basically the only way to get support with that.
Okay, cool. Any questions? Oh, more. All right, so while I read these, I have a question. You mentioned this at the beginning. You said you weren't going to get into it, so we can get into it now. The ethics of volunteer labor. And this, huge amount of work that goes into it.
Yeah, it's really complicated. So Ash Dryden wrote an amazing blog post on the ethics of volunteer labor in open source. I highly recommend you read that. I don't actually have, normally I have like a talk specific link on my website with like links to resources and stuff. I haven't put that up yet, so I'll put that up soon, and then you can maybe take a click there. It's funny because like Debian has had like this weird problem with sustainability. Like long ago there was this goofy project, like sort of GitHub-esque almost, called Dump Tank. And like the project was just outraged over it. The idea that certain developers could get like monetary contributions for their work, but then other developers were kind of like left out to dry. You know, they were doing all this work, but nobody cared about that work, therefore they don't get paid. So that would kind of suck. So like a lot of people who work on the project, for example, are like paid by full-time employers who just work on Debian. Debian does take some money via like the LTS project. So like, for example, there are some people who get paid to work on Wheezy, which is like old stable, because some big companies still want support for that, and so they pay money and they get the support for that. But yeah, that is like a whole talk in and of itself. So
yeah. I mean, you pushed this on December 30th. I
yes.
assume you were on vacation?
Something like that.
Vacation.
Yeah.
Vocation. Tom Marble asks, why is it required to build offline?
Why is it required to build offline? That's a great question. So if you build online, that would basically cause you to be like, okay, I don't have dependencies in like, line captures them usually in your home directory, and then there's a like .m2 folder where it puts a little Maven repository, and so first of all, you don't even have a home directory when you're building in Debian, so we have to like set that explicitly. But then the other issue is, like during a Debian build, you can't like pull in source, like randomly pulled, really like binary, so you randomly pulled down from the internet. That would not be, like, you'd have no idea if that was actually free.
So do you like flip a switch, or you pull your network cable out, or?
Well, yeah, no, so, FTP Master, who is a group of people that like basically watch for all the initial uploads into the archive, and they like say yes or no, they are the gatekeepers. They look for that kind of thing, and they're like, this is clearly like a violation of the Debian Free Software Guidelines. You've got this pulling random binaries from the internet, that you can't do that. So
I see. So it's all about like your rules file. And,
Yeah. Well, so yeah. And so in this case, like, but Leiningen has an offline build mode, so you can tell it, don't do that. Like, don't fetch stuff from the internet. And also, I want to override your local Maven repo. I don't want you to look in home, like /m2. I want you to look for an example. In this case, Debian /Maven repo.
This one I don't understand. I'll get to it. Is there a good intro to how to do this? To package stuff up to Debian?
So in general, I have not found a good introduction to Debian packaging. There are like, I can think of at least off the top of my head, like 4 different ways to build a Debian package. And like every single one of them doesn't have very good documentation. There's not like one true, I think there is like one true Debian build tutorial, but like it basically relies on your software being C code. So if you don't like already have like an understanding of how to build that C code, if you've got like a Python thing or like a Java thing, like every team in Debian, every language team in Debian has their own different way of building things. And like the Java team, for example, does not have great documentation. So like on the Clojure side of the house, I actually put together a small tutorial on how to build packages with git build package, like how to manage like pulling in the upstream tarball, how to deal with the fact that like, you know, upstream didn't actually tag their releases because in a lot of cases I had to deal with that sort of thing. And then it walks you through, I wrote a tool called Clojure Helper, which basically is a bunch of templated like Debian files, and so you just fill out some information and then it sort of tries to do all that. But it's not like perfect. It doesn't do all the things.
Join IRC will help you out.
Yeah, we also have an IRC channel, Pound Debian Clojure, Clojure on OFTC. So if you want to join IRC and pester us. That was basically how I figured a lot of the stuff out, was like going and finding a Debian developer and being like, hey, I don't get this. How do I do this?
Cool. So these 2 questions are kind of related. So what is the plan for CLJ?
What is the plan for CLJ? Oh, it's like complicated. So, I didn't realize that like CLJ wasn't a thing in general, and I guess upstream only like introduced it when suddenly now you had to deal with like 3 different jars for Clojure as opposed to the single jar. Because apparently like, come on, scroll. Sorry, I'm trying to find the building Clojure the hard way thing. Where is that slide? Like apparently doing this, where is it? Apparently doing that's like totally reasonable, but putting 2 other things on the class path is not reasonable. So like Debian already had a Clojure wrapper for this that like wrapped all the stuff, like it basically a user bin Clojure script. And the thing is, like, I didn't even know that, like, that was what was happening under the hood. Like, I actually had to find a script and dig into it to figure out how this stuff worked. So, anyways, like, Debian already had one of these things with RL wrap and everything. Like, we had just done this. Like, from the initial version of Clojure that we packaged, this was just already done. So, but now, of course, that varies from the upstream thing. So now we're probably going to have to, like, package the upstream thing separately and then, like, make that a dependency of this or something like that, such that we can use the upstream Clojure script instead of, like, our fancy, personal, magical Clojure script.
Okay. And what about CLR and CLJS?
Oh, so I believe that Clojure script, like you should be able to just, once you have Leiningen, you can like add the Clojure script compiler dependency in your project.clojure, and then like you shouldn't need to have that as a separate thing you need to install in your Debian system. Leiningen should take care of that for you, but I don't actually write Clojure script, so I wouldn't know. CLR, that's a complicated question because I don't know what the state of like .NET support is on Debian. Like, I know that we packaged Mono, but I don't know if Clojure is, like, compatible with Mono, or the Clojure CLR implementation. So, if somebody's interested in that, like, absolutely hit me up. I'd love to chat about that.
Any more questions? No? Yes?
You said, you hinted something about the just-in-time compiling.
Yes.
Could you talk more about that?
Oh my goodness. So I had to like cut a lot of information about that, and I was really bummed about that. So yes, so Clojure normally, like in a library context, does just-in-time compilation. And this is actually super important to like make Clojure work because libraries in general, they're always API compatible. So like Clojure code from like 1.1 or 1.5 or whatever, like Clojure should always basically be able to handle that. But compiled code, like AOT compiled code, is not ABI compatible. So like if I compile a library for like say, like I compile it with Clojure 1.8, and then I've got this library that's like AOT compiled, and I like don't include that source, and then I try to like build that as a dependency in a different project with Clojure 1.9, that would like blow up. So we have to have that source code there. And as a result of that, like you don't necessarily always know when it's going to like just-in-time compile versus when it's going to AOT compile. You would basically have to keep copies of like, yes, for all these libraries, I have like, these are the ones I compiled with 1.8, and these are the ones I compiled with 1.9, and so on, and pull those in as needed. Now that's from a Clojure perspective. From a Java perspective, it would make tons of sense not to include the source code in your libraries, but from a Clojure perspective, it's like absolutely crucial. You can't hold stuff properly. Any more questions?
No? Well, then we're going to break. Thank you so much, Elana.
Thank you.
So after 10:45.
Cut my mic. Oh yeah, super quickly, I wanted to thank these wonderful people for helping me with my talk, and my employer for sending me here, or well, really letting me be here. I will put information about the talk up on my website. That will be where the link will show up. Thank you, and thanks to Eric.